Welcome to a statics problem in which we are trying to find the centroid of this shaded area right here. Right, so we want to find the x and y coordinates of this little shaded area right here. Now we have this equation of this sort of cubic function, y equals 1 plus x cubed over 8. We're given the area. We want to find the area between the x coordinates from 1 to 2. So we kind of have this little bounded area. It's not like we're starting from the origin or anything. This is kind of like a bounded area that we want to find. So let's go ahead and attempt this problem and see what the centroids are. All right, so let's go ahead. First thing is first. Let's go ahead and make our cross-sectional area. So I'm going to draw a little cross-sectional area, and apologies for the unneatness of the straight lines. So this, I'm going to make our cross-section with respect to our x. So this thickness right here is going to be our dx. Okay. Now our centroid of this particular cross-sectional area is going to be right at the center of it, of course. Now what is our x and y bar? Okay. So we need to know what y bar is, which is this distance over here to the centroid of this piece. So this is our y bar. And then we want to know what this distance here to this centroid on the x axis. So that's our x bar. Okay. Well, as we can see, our x bar, I'm going to write this up here, our x bar is actually just going to be equal to whatever x value we plug in, right? So we go a certain distance x, and we're at our centroid, and you can clearly see that right here. So we go a distance x in this particular cross section, and we're right smack in the centroid right there. So x bar is actually just going to be x. Now what about our y bar? Let's go ahead and find our y bar too. So our y bar is going to be our y, our distance y. This is our distance y right here. I'm going to label that distance y. But that's not the distance to the centroid. Our centroid is down here. Now, remember when I said earlier that our centroid is actually going to be halfway up here. So this is actually going to be our y, right, all the way up here. Half of that. It's going to be half of that. So y divided by 2. So our y bar is going to end up being y over 2. Okay. That's the trickiest part. Okay. If you get this, then you should be golden. The rest of the problem should be pretty straightforward. Okay. Now I'm going to erase a little bit of this to kind of save on the neatness. Okay, I'm going to leave the x and the y bar there, the x bar and the y bar still there. Now what is our dA? Let's go ahead and find our dA, because that's crucial to finding the centroids of our scenario here. So our dA is going to be this area of this cross section we created. So we invented this area. So this area is actually going to be whatever our y is. Our y is this, right? This is our distance y. This is our height. We can call it our height y times our thickness dx. Okay. So we have our dA. Now we want to know what the integral of dA is, because that's going to be ultimately our area of this entire figure, because we need to know what the area is. So the area is the integral of our dAs. So it's going to be the integral of y dx. Now we have two variables here. We need to get this expression in terms of one variable. How can we do that? Well, we can just simply replace y with this equation, because our y is basically our curve right here. So let's go ahead and do that. So our y, let's say this is equal to, just substitute y for this equation right here. So it's going to equal, and I have to scroll up because I forgot what that was. It's 1 plus x cubed over 8. And all of that is multiplied by dx. Okay, great. Last step we want to do in solving for our area is what are our limits? Or in other case, what goes on the bottom here and what goes on the top here, our bounds? Well, if we add all of our infinitesimally small rectangles, pretend that all of these rectangles are infinitesimally miniature, our bounds are actually going to be from this point right here. We start from 1 and we go all the way to 2. So that's our stopping point. This is our beginning point. This is our stopping point from 1 to 2. Okay, great. So we have our bounds here. We have everything in terms of one variable. We can go ahead and solve for this area right here. So let's go ahead and integrate. So we're going to get x plus x to the 4th over 32. And we evaluate this from 1 to 2. Okay, so this is our step from integrating right here. So make sure you know how to do that. If you don't know how to do that, if you don't know how to integrate polynomials, that will be in another video to brush up on your integration skills. Okay, now let's go ahead and evaluate this expression right here. So we're going to have just plug and chug. So 2 plus 2 to the 4th, which is actually 16 over 32, subtracted by 1 plus plug in 1 here. It's going to be 1 to the 4th, which is 1 over 32. All right. And for the sake of time, this actually simplifies to 47 over 32. Now, if you want, you can go and do the extra steps, combine your common denominators and make sure you add and subtract correctly here. And you should end up getting 47 over 32 as your area of this whole thing right here. Okay, so that's our first step done. Okay, so I'm going to say that this is our integral of dA. And I'm going to go ahead and erase all of this stuff because we're going to need some room here to go ahead and evaluate our x and y coordinates of our centroid right here. Okay, so let's go ahead and solve for the x coordinate first. I don't know, I guess it's just by convention people normally solve for the x value first. So it doesn't really matter. So let's just go ahead and start with our x coordinate. Now we know that it's going to be our x bar times our dA over the integral of our dA. Okay. This is a formula that should be in the back of your mind. All right. Now let's go ahead and solve for this integral. So let's go ahead and plug our values. So we know what x bar is. We set that to be x. So it's going to be our integral. Now, what are our limits? Well, we'll get to that in a second. Once we plug all of this stuff in, it'll be a little bit more clear to us what our limits should be. And our dA, we said our dA was, it's going to be, actually, I should not have erased that, but it's going to be our y, which is our 1 plus x cubed over 8, right? We already found what dA was earlier, times dx. I did erase that, I do apologize, but if you go back and make sure that that's our dA, right? Because this is our y times dx, okay? And I simply replaced y with this expression right here. Okay. So I'm gonna go ahead and bring this down here so we can go ahead and solve for this integral. Now, this is actually all over dA, right? By our definition, this is our centroid. Okay, so let's go ahead and evaluate. I'm going to put xc over here. This is our centroid of the x-coordinate. So our limits, let's actually tackle that now. So our limits, again, we're adding up all of these centroids, okay? We've solved for all of the areas, the cross-sectional areas, but now we're solving for all of the centroids. So we have, let's put like some dots all around here. So it's going to look something like this, where we're evaluating all of these centroids right here. And it's going to be bounded from 1 to 2, as we've noted earlier. So it's going to be from 1 to 2. Okay, let me get rid of all those dots. So our limits should be from 1 to 2, right there. All right, so let's go ahead. I'm going to go ahead and FOIL these two products right here. So the integral from 1 to 2 of x plus x to the 4th over 8 times dx. All of this over our integral of dA. I'm just going to leave this denominator as the integral of dA. We have solved for this earlier, so don't forget, we're going to use this in a little bit. So we're going to have to come back to that. All right, let's go ahead and evaluate this integral up on the top. So our integral on the top is going to be x squared over 2 plus x to the 5th over, should be 40. And we're evaluating this from 1 to 2. And then we have our integral of dA on the bottom. All right, let's go ahead and evaluate this. All right, so on the top, we should have 2 squared, which is 4. So 4 over 2 plus 2 to the 5th power, which should be 32 over 40. Okay, now let's subtract that with our bottom bound. So 1/2 plus 1 over 40. Okay. Oh, sorry, 1 over 40, not 40. 1 over 40. All right. So this is our evaluating this expression. Now we can go ahead and plug in dA if we want. So let's go ahead and plug in dA, which we said that to be this guy right here. It's 47 over 32. Now you can go ahead and simplify this. This is just basically numbers, so just use your mathematical abilities or your calculator, and we should end up getting our x coordinate of the centroid to be 1.549. Now, do we have units? No, there's no units, so we're just going to leave it as 1.549. All right. And that is our centroid right there for the x-coordinate. All right. Now, we can go ahead and solve for the y-centroid, the coordinate of the centroid with respect to the y-axis. So let's go ahead and do that. So our y bar, keep in mind, is y over 2. So let's go ahead. I'm going to go ahead and do our y coordinate of the centroid right here. It should be our y bar times dA over the integral of dA. All right. Now we said, remember, y bar, we found that to be y over 2. And our dA, we said that to be 1 plus x cubed over a times dx. Okay, and our bounds should be from 1 to 2 because we're adding up all of these infinitesimally small dx's right here. Okay, Now we want to replace this y in terms of x because this we have two unknown variables here. We need to have one unknown variable. Now let's put our integral of dA on the bottom. So y, remember we said is 1 plus x cubed over 8. So let's go ahead and plug that in. So it's going to be integral from 1 to 2 of 1 plus x cubed over 8. This is divided by 2, right? It's y divided by 2. So this y divided by 2 times 1 plus x cubed over 8. All right. Times dx over our dA. All right, well, we can take out this constant, right? This constant of 1/2, so we can take that out. So we'll have 1/2 of the integral. Now let's go ahead and FOIL right here. So this is basically, if we take out this 1/2 and we bring it out here, which I did already right here, this is actually 1 plus x cubed over 8 squared, right? These two expressions are exactly the same. So let's go ahead and FOIL. So we're going to have 1 plus, this should be x cubed over 4, right? We do 2 of those. And then we have x cubed over 8 squared. So it's going to be x to the 6th over 64. And all of this is multiplied by dx. And then all of this is divided by our integral of dA. All right. So let's go ahead and evaluate this integral. Now we're getting to that step where we can evaluate the integral. So we have our 1/2 over here times our x plus x to the 4th over 16 plus x to the 7th over 7 times 64. Let me see what that is really quick. It's 448. All right, and we're evaluating this with respect to x, from x equals 1 to x equals 2 over our dA. All right. So the rest is basically just plug and chug. So go ahead and try to see if you can do this on your own. I'm not going to simplify this. So you should end up getting the y centroid to being, once you evaluate all of this and replacing dA, remember replace dA with 47 over 32, remember? So, oops, that was a bad circle. Circling around this number. So we should end up getting our y centroid to be 0.756. All right. So that's our x, or our y centroid. Our x centroid is 1.549. All right. So that's it. Let's go back up here. Does this sound reasonable? Well, our centroid has to be within the area of this thing, right? So let me erase this. 1.549. Keep in mind that this is our x-coordinate of the centroid. So it is 1.549 is somewhere in between this area. So that is reasonable. So that does make sense why it would be 1.549. And then our y-coordinate we said was 0.754, or sorry, 0.756. So our y-coordinate somewhere, I guess, somewhere around there, maybe a little bit higher because it's closer to 1. So that is our y-coordinate of the centroid. So 0.756. This is 1.549. All right, there you have it. That is the centroid of this lovely figure right here. Hope you learned something today, and I'll see you in another video.